Okay, let's continue to learn Attrasoft Image Deep Learner. Now we come to the 5 layers. 5 layers is computationally expensive. Therefore, we must match the architecture with the problems. When you have 4 layers, usually you have two choices. One is for concept identification with 1 layer for features, 1 layer to collapse the features to group a category. That's still very fast. If you use 4 layer for object recognition, then that's somewhat slower. When you go above 4 layers, it's almost always computationally expensive. And also, therefore, you must match the deep learning architecture with the problem you're trying to solve. So in some sense, we go back to square one, that when you have a multi-layer, the deep learning is become a manual process again. Well, but it's one level higher than the earlier. We said the first iteration is programming, labor intensive. The second iteration of learning is machine learning, which has learning algorithm but manually crafted features. So the manual feature engineering is very expensive. By the time we reach the third layer, third iteration of learning, we have representation learning, automatic feature generation, automatic learning algorithm. Everything is automatic, so things doing very fast, very accurate, but it requires the normalization of the images. So you can, in the very controlled environment, you can identify the object very fast, very efficiently, and without programming at all in the fully automatic process. When you go beyond the representation learning to go to deep learning, we are going to address a bunch of new problems, mostly the variation of images. Variation are things like relative distance between parts, scales, rotations, translations, flipping, light conditions, data acquisition from different devices, some nicely good catalog images versus newly captured images, all these kind of things. And so you have to be carefully match what your problem you try to solve to the deep learning architecture. That, at least at this generation, that's a manual process. So this is not the earlier manual labor. The earlier manual labor is concentrated on handcrafted features. About third generation of learning, everything is automatic in that aspect. But we're still doing manual labor in a higher level. So we briefly talk about 5 layers. Here is the first layer. Here's the second layer, third layer, fourth layer, fifth layer, sixth layer. So the first layer and the last layer is always the same. We repeated that many times. So first layer is the curve identification. The last layer is the supervised learning. The second layer, we get features from image segment. And then the third layer, we combine the features together. And the first layer we build on top of that, either for concept identification or you really have a complicated object. Let's briefly talk about this the layer in this, or to here. This is our design. In the bottom layer, we have a nice segment. And then from 4 segments, we get one more segment in the layer higher. And then these 4 segments, we create a new layer. So that's basically the architecture we use. We do a random problems, not particularly address a problem type of problems. So in the bottom layer, we have a nice segment. and we combine 4 segments together to get one higher layer. And then in the third layer, we combine four the third layer to get into the fourth layer. And the fifth layer is supervised learning. Okay. So now let's look at the problem we're trying to solve. The last example here, chapter 7. And the features we're saying we're just randomly pick up some images. We learn 5 features. 5 concepts. So some random features, those are randomly downloaded images. Ships, TV. So we're pushed through this this concept through the 5-layer architectures, and we do push through one by one, and then in the last layer we do some testing and the redistribution software. Those are identical to the 4-layer architecture and the 3-layer architecture. Okay, I'll see you next time. Bye.